There are two types of metal constraints. There's the metal-ligand interaction constraint, and then there's the metal coordination constraint. The metal-ligand interaction constraint, also just known as a metal constraint, is a requirement that a particular metal-ligand interaction is present when the ligand is docked. The ligand atom must lie in a sphere around a specified receptor metal atom, which means that the constraint on the ligand atom has no directionality. Setting up a metal-ligand interaction constraint is similar to an H-bond constraint, but where the receptor atom is a metal ion. Simply ensure Pick is checked on, then select the metal on the workspace. Similar to the metal constraint feature is the metal coordination constraint, which also requires a ligand atom to lie within a specified distance for optimal binding with the metal. But, unlike the metal constraint, the metal coordination constraint incorporates directionality by identifying possible coordination sites on the metal, and then allows you to use any or none of the sites found. So in this particular example, if we ensure Pick Metal Atom is checked on, and then pick the metal in the binding site, we'll first see the red sphere representing the region that the metal binding group must be located in, and then in the table we can see the coordination geometry listed as tetrahedral. In this other example, we can see that the receptor metal creates two sites defining octahedral coordination geometries. Now, since in this case ligands can only approach from one direction, we can turn off one of the sites by unchecking the box in the Use column. If you want finer control over the orientation of the site from the initial location, you can select Rotate, and then rotate the orientation of the coordination site around the metal with the usual actions for workspace rotation. You can also edit the XYZ coordinates in the table, as well as edit the maximum distance or rename the metal coordination constraint.